This is the briefing video for the tin iodide experiment. So what you're doing in this experiment is you're reacting elemental tin and elemental iodine together and making tin iodide. And so the purpose of this experiment is to give you practice at performing the sort of synthesis and analysis skills that you've done learnt in previous experiments, but it's also the purpose of this experiment is to introduce to you how to perform titrations, which is a method used to sort of analyse and quantify how much of a particular compound you've got. And for this particular experiment, the reason you're doing a titration is you're using it to confirm that the empirical formula of tin iodide is indeed SnI4. So there's basically 1 part of tin to 4 iodines. So as part of this experiment and the pre-lab exercises, you have some pre-lab videos to watch. So do make sure you look through them, particularly focusing on techniques that you are unfamiliar with, so that you know how to do them. There will be some questions in the pre-lab exercises about performing these techniques correctly. Okay, and so this is just a kind of overview of how the experiment should run for you. Okay, so you've got 2 days to complete the tin iodide experiment. The first day really sort of concerns the synthesis part, making tin iodide. So in the morning, you will be sort of setting up and running your reaction under reflux to make your tin iodide, and then in the afternoon doing the purification to isolate tin iodide, and as a pure material it will be an orange solid. So then on the second day, after you've made tin iodide, you can then do the titrations, and the titration should really take a sort of a morning session. So we have got some extra time for you there, so if anything happens with your experiment, or perhaps things are taking a bit longer than expected, everybody should still be able to finish the experiment within 2 days. Okay, so make sure you're familiar with the hazards of these experiments. In particular, they're in the scripts. You need to make sure you look through them, what the chemical is, what the hazards are, and what precautions you should take for sort of handling and using these reagents correctly, as well as how to dispose of them. So in this particular experiment, some of the key hazards are listed here. So chloroform and iodine are hazardous, harmful chemicals. In particular, chloroform has harmful vapors, and it can also be toxic if it's absorbed through the skin. So you need to make sure that you're wearing gloves and you're not sort of breathing through the vapors. So chloroform needs to be kept in the fume hood. You're using flammable solvents like petroleum ether, so you need to make sure there's no sort of naked flames or sparks near petroleum ether. Also, if you're heating the petroleum ether, you don't have lots of vapors that could come in contact with the electrical hot plate. And you're also using corrosive reagents like hydrochloric acid. So you need to make sure that you're wearing gloves, so this won't sort of cause skin irritation, and also that you dispose of the acid correctly, so you're diluting it down before disposing it down the sink. Okay, so I'm going to talk a little bit more about the titration you're doing at the end and how it should work. So it's called the Andrews method of the titration. There's more detail about how it works in your script, so you can read through it in there as well. But as I mentioned before, the whole purpose of this is to confirm that you've got the tin iodide formula that's given in your script and at the start of this presentation. And so what happens here is potassium iodate reacts with your tin iodide sample, and what you should be able to confirm is that based on the amount of iodate that you use and you titrate, okay, you can confirm that you've got 4 iodides present, which comes in from the tin iodide. Okay, and so these are the 2 overall equations of what happens, the reactions that happen and take place in the Andrews method of titration. But the overall, what you should find is that for however many moles of iodate is used for the colour change in the endpoint of this titration, confirms that you've got 2 parts of iodide present. And then, so based on the number of moles of tin iodide that you use, you should be able to actually confirm that you have 4 iodides compared to how much tin that you have. And there's more guidance in your experimental script to show you, like, once you've got your titration value, how you actually then do that calculation to work out that the empirical formula of tin iodide is SnI4. So in this titration, what happens is you're titrating into a conical flask, and there'll be 2 layers, an aqueous layer and a chloroform layer. And it's in the chloroform layer, which is in the bottom layer, that you'll see a colour change occurring. So what first happens is you get a first equivalent of iodide reacting with iodate, reacting with iodide to give you, which comes from your tin iodide sample, to give you iodine, and this will give colourless to pink violet, so colour in the chloroform layer. So what after that chloroform pink violet colour appears, then a second equivalent of iodate reacts, and it will react with the iodine again, and this time turn it back from being pink to colourless. And so when this happens, this is the end point of the titration. Okay, so the second colour change going from pink to colourless, this is what you're looking for, and that will give you then the total amount of iodate needed to give you this overall titration. One thing you can do if you're unsure about how these 2 equations work together to give you 1 equivalent of iodate to 2 equivalents of iodide is you can actually combine them into a balanced equation. Okay, and so something that this experiment has, which I think you won't have experience with the other experiments, is after you've performed your titration, you've actually got to do these calculations to work out the empirical formula of tin iodide. So as I've mentioned before, the guidance of this is in your script, and there's 2 parts to this. The first part is to help you then take that titration result and work out how much a percentage mass of iodide you had in tin iodide. And then the second part is, once you've got that percentage mass of iodide, you can then actually calculate the empirical formula. And the empirical formula that you should end up with should be close to showing that you've got SnI4. It's unlikely that you'll get exactly 1 part tin to 4 parts iodide, but it should be close to that value, and that should then confirm that the empirical formula is SnI4. Okay, so finally I'm just going to end the briefing video with some tips. The first tip is related to the reflux of the reaction. Okay, so there's no actual time we tell you to heat this reaction under reflux. It's until you see a certain colour change occurring. So what happens is, when the reaction starts, the iodine that you see starts off giving off brown fumes, which you can see in the bottom of the condenser, and it starts turning paler, it starts turning pink. And what you basically need to do is know when the reaction is finished, and you can move on to the purification stage, is keep an eye on this colour. So the colour should either the brown to pink colour should go fainter, ideally completely disappears, but if not, it goes to a faint pink and it holds at that pink sort of colour. And what this shows is that basically the iodine has reacted with your tin, but then it's sort of no longer reacting. And at this point where you see sort of faint colour that's no longer changing, that's when it tells you that the reaction is complete. It can take anywhere between 30 or 90 minutes, and so you need to sort of keep an eye on this colour change until it's happened. And then the next tip relates to the titration that you're doing. You need to sort of run the titration until you have sort of two sort of concordant results. And so the advice is to just start with a trial run just to get a rough idea of how much iodate will react with the tin iodide sample that you've weighed out. And then once you've done that, you can sort of in your sort of second or third attempts run the titration much more slowly once you get near to the approximate endpoint, so you get the exact value that you need. The other thing as well to do with this titration is, as I mentioned, there's two layers to this, an aqueous layer and a chloroform layer. To actually get the colour change to occur, you actually need to kind of stopper your conical flask and shake it, and then add a little bit more of your iodate, stopper and shake it until you see the colour change. So do make sure you're really sort of shaking, mixing the two layers together, because that's what makes the iodate, which will be in the aqueous layer, sort of go and react with your tin iodide sample, which is going to be more in the chloroform layer, and where all the iodine is, where the colour changes are occurring. Okay, so that's the end of the briefing video.